Reconstitution of solutions is the most challenging section. So if we're going to do a reconstitution, we're going to take a solvent, a solute, a solvent, and a solution, and we're going to call them in parts. So our solute, concentrated, right? That is, for example, if you go to Walmart and you buy those packages to make Kool-Aid, this would be my Kool-Aid package. And we're going to add it to some water, which is our solvent. And it's going to equal my solution. Okay? So, process of mixing and diluting solutions terms solute, substance to be dissolved or diluted, can be solid or liquid. Solvent is a substance liquid that dissolves another substance to prepare a solution. So in this case here, I called this Kool-Aid, my solute, plus my water, my solvent. And then solution is equals to my resulting mixture. It's what we're going to have in the end. It says caution, reconstitution injectable drugs, read and follow the label or package insert directions carefully. So some drugs do call certain methods of reconstitution. So that's saying, I don't want to get into the science part. I just want to talk to you about the math part. So it's very important that y'all read this section and understand it. And again, I know it is very challenging. So we're going to determine both types of the amount of diluent to be used, determine the volume of the milliliters of diluent to be used for the route as ordered, reconstitute the drug and not the resulting supply. Here's a picture of taking a solvent or diluent of 4.8 milliliters of sterile water, and we're going to put it in with our concentrated, which is Kool-Aid, and it's going to give me my solution. This is a good example of a label. When it's been reconstituted, you got to put the date that you mixed it. You're going to put the time you mixed it, and you're going to put reconstituted as what? In this case, 100 milligrams per milliliter. You're going to put when it expires, because a lot of times when you reconstitute something, if it's a multiple dose, it will expire in 7 days. If it's a single dose, then that means it already expired as soon as you used it. And you're going to put what time, and you're going to put the directions. In this case, it's refrigerated, and then you're going to put your abbreviations and your like if you're LPN, it'll be LPN, and then your initials. So let's do mathematics on this. It says that we have an order of 225 milligrams intramuscular every 6 hours. This is another diagram of how to do that. So let's find that slide to finish this one. Let's come back to this one. I apologize, guys. Let's keep on going for right quick. A rule: when reconstituting multiple doses injectable medications, verify the length of the drug potency. Here you go. If it's a multiple dose, we have to follow these steps. I encourage you to know them. A math tip: when multiplied, directions for diluting are giving. The smaller the amount of diluent added, the greater or stronger the resulting solution. So basically saying, if we go back to this Kool-Aid right here, if I put more Kool-Aid powder than I add on the water, so if it says add a gallon of water to 2 packets, but instead I only added a half a gallon, then it's going to be like super strong, right? So that's what that is saying. But if I add twice that, or say I add more water than it calls for, then it's going to be really weak tasting. It's going to taste more like water. So that's what it's saying in this one slide. Okay. So here's our supply to that one question. Let's come back up here to this order. So we have 225 milligrams intramuscular every 6 hours, and we have a supply. So I'm going to go ahead and write this right here. A supply of 500 milligram vial of powder, intramuscular or injectable, or excuse me, IV injection. It's reconstituted at 8 milliliters. This typical type of water with benzene alcohol. And then it says that we have, see, and I don't want to get into the science of all this, guys. But anyways, so we have 500 milligrams of this. So what we're going to do is we're going to take this 500 milligrams, right? It's my supply for every 8 milliliters. We have an order, we have a supply. So if I was to solve for this, I know that 500, right, 500 divided by 8 gives me 62.5 milligrams per milliliter. And this is how we want it, right? And if you notice, it was already done for you here. It's not always going to be done for you. So here's my supply. Here's my order. And if I want to know how many milliliters this would be with the order, we know we take this 225 divided by 62.5, right? So it says, what do we know first? We know that after we dilute it, we get 62.5 milligrams, right, per milliliter. We know we have an order of 225. So moving on. So in the vial, it says there's 500. The order is, okay, so it went back to the order as 200 instead of 225. I apologize. I should have caught that as a typo. But anyways, so we know the vial has 500 milligrams in it. And the order calls for 200 or 225. It doesn't matter. We know in when we reconstitute it, we're going to have 2 doses, right? 2, because if we cut 5 in half, it's 250. So as long as it's a multiple or dosage, then this is going to be 2 doses, right? 2 different times you can use it, so you need that label on there. So that's what this question is getting you to focus on. So now it says when we convert these two, we got the order of 200 milligrams, and we got our supply of 62.5 milligrams per milliliter. We want to convert it to see how many milliliters it is. So let's do that. Let's take that 200, divide it by 62.5 milligrams times 1 milliliter. And when we take that 200 divided by 62.5, it says that we have 3.2 milliliters. Of course, you want to think about it. You want to give more than 1 milliliter. You want to give more than 3 times 1 milliliter. So that's what it's saying. That's just a sentence version of it. So now let's talk about the solution strengths. A fraction expresses a strength of a solution made from a liquid concentrate. The numerator is the number of parts of solute. The denominator is the number of parts of solutions. Remember, solution is everything. It's the final, so like it's my Kool-Aid that I get to drink, right? And then my solute, again, what was our solute? If you need to, go back up here at the top and look at it. Solute is the actual Kool-Aid powder that we're going to mix with the water. So back to here. So this here is going to be how many package of Kool-Aids we're going to add, right? So it goes here in the numerator, this goes in the denominator, and the difference between them will give you your final part of solvent. It tells you how much water to add. So for example, let's talk about that. Say that you are given this example. It says we have 1/3 strength of nutritional formula. So say someone's on a feeding tube and they're having to get 1/3 strength. We know that the 1 part concentrate, this would be my Kool-Aid package, right? 1 Kool-Aid package. And this is 3 parts of the total solution. So this is the actual Kool-Aid. It's the finished product. How much water do I need to add to it? We say 3 minus 1. Take the denominator and subtract it from the numerator. See it? Gives me 2. That means we need 2 parts water. So to prepare a solution, apply a formula to find amount. So we have our desired solution strength times our quantity, and it gives us our amount. Okay, so I would write this down. So we have an example to work. Let me see an example. It says a physician orders a patient's wound irrigated with strength of 2/3 hydrogen peroxide. So again, 3 is the total solution. 2 is the solvent, right? It's the hydrogen peroxide. How much, how much solvent do we need? We subtract them. 3 minus 2 gives me 1, so it'd be 1 part solvent if you had to figure that out. Normal saline solution every 4 hours while wait. 60 milliliters per irrigation for 3 irrigations during your 12-hour shift. So we know that we're going to give them 60 milliliters per 3 irrigations. So we're going to say 60 times that 3. That's going to tell me how many milliliters, right? Total solution, right? Because we're going to do 60 milliliters per, meaning every 3 irrigations. Okay. And then it says how many stock hydrogen peroxide and normal saline will you need? Well, let's convert if needed. In this case, it doesn't need 1. So we want to take our 2/3, right? We want to break it down, and we want to say 3 minus 2 gives me 1 part saline. So that means for every 180 milliliters of solution, you will need 2/3 of it as solute, which is 120 milliliters. And then 1/3 of this solvent is 60 milliliters. Okay. So we know that 60 milliliters, let's look at that. 60 milliliters is my solvent, right? And we're going to irrigate it 3 times during the 12-hour shift. Gives me a total of 180 milliliters. Here's our total of 180 milliliter solution, right? If I take that 180 milliliters and subtract the 60, again, total minus part gives me 120 milliliters. This gives me my solute. So this is how you solve these problems. If you have any questions, please ask me. Thank you.